Okay, this time I've chosen a tricky one. This time there's 3 statements here. So the precondition is true, and what's the code doing? It assigns m to the value of x, and then increases m by y, and then increases m by z, and then afterwards m is equal to the sum of x and y and z. So here we're going to have to use a sequencing rule twice over to break apart the code into 2 parts and to break it apart again into 3 parts. So if we want to prove this statement, all I can really do is apply the sequencing rule backwards. So we'll do that. So I need to prove true. I need to prove 2 things, in fact. I need to prove true, and then we'll break it into the first 2 parts and the last part. So m is assigned to be x, m is assigned to be m plus y, and then some condition q, we don't know yet, I'll leave it blank. That same mystery condition, increase m by z. Our post condition is m is equal to x plus y plus z. Okay? How can I fill this rule in? Well, I can do assignment rule backwards. So what would have to be over here, such that if I replaced m plus z with m, I would get this over here. Alternatively, what happens if I replace the m's with m plus z? Well, I'm going to get m plus z is equal to x plus y plus z. Okay? Now I have to use the same post condition up here. M plus z is equal to x plus y plus z. Okay? So if I can prove these 2 things, I can then prove this thing by sequencing. And thankfully this thing here is the assignment rule, because I rigged the precondition so that it would work with the assignment rule. Okay? So this rule is proven. I just now got to prove this rule here. Well, again, we've got some redundant stuff, so we should clean this up before proceeding. I'm going to replace this, I'm going to subtract the z's off both sides. So m plus z equals x plus y plus z is logically equivalent to m is equal to x plus y. So I can use precondition equivalence backwards. True, m is assigned to be x, m is assigned to be m plus y. My post condition is now m is equal to x plus y. Okay? So if I can get to here, now everything's proven. So I'm sort of making the problem easier and easier as I work my way up. Okay? So here again, we've got 2 bits of code. We have to split it apart. So I have to do the sequencing rule again. So I've got true. First bit of code, m is assigned to be x, and then some mysterious post condition we'll work out in a bit. Same mysterious post condition. M is assigned to be m plus y, and then this post condition here, m is equal to x plus y. So if I can prove this for some q, and if I can prove this for the same q, I can put these 2 things together to get this statement here by sequencing. Okay? So how can we prove this statement here? Well, assignment backwards worked before. Good odds is going to work again. Replace the m's with m plus y. So m plus y is equal to x plus y. So this rule is true by assignment. Copy the same precondition here to become the post condition here. M plus y is equal to x plus y. Okay? How can we prove this statement? We've got a true over here. Trues are difficult to deal with, so we'll try to do assignment backwards from here and see if we can get to true. So m plus y is equal to x plus y, and I made the assignment m is assigned to be x. Well, I can do the assignment rule backwards and replace the m's with x's. That's going to give us x plus y is equal to x plus y. And then, hooray, these 2 things are going to be logically equivalent, right? Because x plus y equals x plus y, that's always going to be true no matter what. Let's move that over a bit so I can see my rules a bit clearer. So x plus y equals x plus y, logically equivalent to true. So I can get from here down to here by precondition equivalence. Cool. Proof is done. Now I can put in my line numbers, justifications. 1, 2, 3, 4, 5, 6, 7, 8, 9. So rule 1, that was line 1, that was assignment. This was logic. Line 3 is going to be precondition equivalence using 1 and 2. Pre-con EQ 1 and 2. Line 4, that's already done for me, that was an assignment. Line 5, how did I get here? So this is my P, this is my Q, this is my same Q, this is my R. So I can put these two statements together. Do this code first and then do this code second using the sequencing rule, which is this rule here. So sequencing lines 3 and 4. Okay, line 6 is just logic. Line 7, how do we do that? I've forgotten. Oh, the post condition. Post condition equivalence, because this thing here is the same as this thing here by line 6. So post con equivalence line 5 and 6. That was an assignment. So again, this thing here, I'll do it in a different color. Where'd my red pen go? Here it is. This is P. This thing is Q. This same thing is Q. This is R. So that means I can do all of this code followed by this code all together with P over here and R over there using the sequencing rule. So this is going to be sequencing lines 7 and 8. And there we go. That's how you do sequencing when you've got more than 2 bits of code.